Welcome, class, to Chemistry 111. We will finish talking about naming today. We had previously go through a quick of what we went through before, but we go through naming. We're going to finish with acids and bases. But before we get to that, I'm going to quickly do a review of what we've learned so far. Course now, molecular. I might need to write bigger too. But basically, bimolecular is non-metal plus non-metal. The whole rightmost quadrant of the periodic table. These guys are going to be, because of the nature of covalent bonds, we're going to have to specify how many of each element. So we are going to have the first guy named like a cation, the second guy named like an anion. The second guy always gets the prefix no matter what, but the first element will get a prefix as long as it's not 1. So if I say N2O5, the first element we call it dinitrogen pentoxide. So we're saying 2 nitrogens, 5 oxygens. So dinitrogen pentoxide. So that in mind. If there's one exception, and that is halogens come before oxygen. So if I said, typically the first element is named first. So you're going to see this as, assuming my marker doesn't die on me, ClO2. We would not call that dioxomonochloride. You would call that chlorine dioxide. But the fact of the matter, we usually name from left to right, so the left element gets named first. So nitrogen gets named first before oxygen. We don't say O5N2, we say N2O5. But usually, based on either the name or the structure, we're not going to be able to trick you. I'm going to have to get a better marker, though. Metal plus non-metal. Our ionic is our metal plus non-metal. And so we can break this into 2 types of metals. We can break it into group 1, group 2, or let's just say aluminum, zinc, and silver. Group 1 are always +1. Group 2 is always +2. And these 3 are exceptions that always have the charge given. I'd say group 3 for aluminum. Aluminum is pretty much the only one we'll see from group 3. These guys will just get their name. Or if you see their name, the charge is already understood. The other guys are transition metals. And we'll either have name plus charge, or we will have to determine the charge by the anion. So either name plus charge, like chromium 3. Would say, oh, that's chromium 3 chloride, I guess, or titanium 4 oxide, or they would have a charge associated with them that we have to state. Now, the anions, we were able to predict the charge of basic anions by looking How far are they from group 8? We say fluorine is group 7, so it's 1 minus. Oxygen in group 6 is 2 minus. Nitrogen in group 5 is 3 minus. And those charges are pretty common. But the last thing we had to worry about is the polyatomics, mostly the oxyanions. But there was occasionally a few other ones, including hydroxide, cyanide, and acetate. So I'm going to go ahead and flip to the next slide. This is the first new slide. We're going to do a practice one, but I'm going to do a little bit more practice. But this is a quick reminder. So what you'll be asked to do on the homework and the test is either turn names to chemical formulas or chemical formulas to names. And that is a process we're going to have to figure out. Let's see. So going over here. Oh, I need to let that. Come on. No. Okay. Okay, here we go. So, more practice. So these are just turning chemical formulas to names. First one, we have iron and oxygen. Oxygen is always 2 minus, unless, except in very, very rare cases. So let's start with the base. The base would be iron. Iron is a transition metal, so we need a charge. We're going to leave a blank for that charge, but the oxygen makes us oxide. Yeah, I'm not sure if you can see that on the screen, so I'm just going to speak what I'm doing. Iron oxide. So I look. There's 3 oxygens at 2 minus. So, and the 2 charge from the oxygen, from the iron, the 2 subscript for the iron, if you swap them over, you see this has to be iron 3 oxide, because 3 plus 2 3 pluses is 6, and 3 2 minuses is -6. 6 plus 6 minus cancel to create a neutral compound. The charges must always cancel to give you a neutral compound, or else it's not a compound. It would be an ion. We always should have a neutral compound in the end. Moving across, there's Cu, that is copper. So copper, it's one of the transition metals. So copper, we don't know the charge yet, sulfide. Sulfur is in group 6. Group 6 is below oxygen, which is 2 minus. So sulfide 2 minus means copper must be 2 plus to counter out the 2 minus. Copper 2 sulfide. The last one, magnesium. Magnesium is in group 2, so that is just as given, magnesium. The OH is a polyatomic, but there's only one charge, only one possibility. OH is hydroxide, so magnesium hydroxide. Nothing fancy, we just have to be able to. Moving on down. We have aluminum, and we have chlorine. So we can just call that aluminum chloride. Nothing fancy there. Aluminum is group 3, so we don't need a charge. Aluminum is always +3. BaCO3. So that one is a little tricky. Barium. I'm not sure. And CO3 2- is the standard one for, it's not carbide because it's an oxyanion. It's either carbonate or carbonite. So carbon is group 3. Group 3 has a maximum of 3 oxygens. So the max is the ATE ending. So barium carbonate. In all actuality, we don't have a carbonite. So unfortunately, we can't freeze Han Solo and store him away and send him to Jabba. There's no carbonite that we have, at least that exists. The next one, potassium Kno2. So potassium, that one's pretty straightforward. It's group 1. But so NO2. It's not nitride because there's an oxygen associated with it. Nitrogen is on row 2. So the maximum we could have is NO. What we have is actually NO2. So instead of nitrate, we go to the lesser ending, nitrite. So nitrite, I'm probably blocking the screen or it's off the screen altogether. But so I look, NO3 is the starting point of 8. It's not NO3, it's 1 less, so it's ite. So moving along. So here's a halogen one. Sodium, ClO4. ClO4, 1-. That is the highest level. Chlorine is group 3. Row 3 can have a maximum of 4 oxygens. But chlorine, once again, is one of those exceptions. All the other compounds only really have 2 possibilities. Chlorine, bromine, and iodine have 4 possibilities, so we have to go through all 4 options. 4 being the maximum makes this, instead of just chlorate, it makes it perchlorate. 1 above the chlorate, because chlorate is the maximum for everything else, so perchlorate is 1 above that one. Next one's a little tricky. HgNO3 2. So there's 2 things. 1, this is mercury. But mercury is a transition metal, so we have to label its charge. NO3, that's nitrate. Now here's where you get a little tricky. NO3 has a charge of 1-. There's 2 NO3s, so a total of 2-, meaning 1 mercury is mercury 2+. So we'd call this mercury 2 nitrate. Mercury 2 nitrate. We have to determine the charge of mercury by the charge of the oxyanion. And that's a little tricky because nitrate is not just one you can look at the periodic table. You need to start learning those. Zinc. Zinc is our exception. Zinc is always 2+ and only ever 2+. So this one's just zinc bromide. No muss, no fuss. Finally, cesium iodide. I'm moving a little faster. Calcium. So calcium, pretty straightforward, but So we have SO3. SO4 is sulfate. So SO3 is sulfite. SO3 is sulfite. Calcium sulfite. And the last one, KIO. This one's really tough. Well, not really tough, but it's tough, at least oxyanion wise, because it comes from IO4. IO4 is per iodate. IO3 would be iodate. IO2 would be iodite. So IO1 minus puts us at hypoiodite. One below iodite. So we start with the base and we work our way down. How many oxygens is it missing? And so, let's see. Thankfully, I'm at least loud, so even though it's not super clear on the screen. Damn shame, though. But so we're going to remove oxygens from the base structure until we get what we actually have. So if you learn the bases and how to name the bases, the starting one, you can look at it from there and change it from there until you got something that more closely fits what you see on screen. Okay. So the last thing we're going to learn about is acids and bases, naming these guys. Now, when we talked about hydrogen-containing molecular compounds, typically they would be named like a binary compound, but in their pure state, like as a gas. So if I talked about HCl as a gas, we could call that hydrogen chloride or hydrogen monochloride. But when we dissolve this in water, it becomes a special compound, which is an acid. An acid is a compound that produces a H plus atom. An H plus, let's think about what is an H plus. An H by itself would have one proton, one electron. When you take away the electron to make it H plus, it is a naked proton. So when we put an acid in water, it will donate a proton that'll start floating around and usually gets absorbed by water to become what's called a hydronium ion, H3O plus. That is the active ingredient in all of our acids, this extra proton that gets added onto water, this hydronium. Notice it sounds similar to the ammonium. Ammonia went to ammonium. Well, hydro, our water became hydronium. When we lost a proton to become OH, it was hydroxide. So when HCl gas goes into water, it becomes an acid. So from hydrogen chloride to hydrochloric acid. Now, most anions can become an acid by adding hydrogen, and including most of the polyatomics. But not all the compounds are necessary in acid. So CH4, okay, that was weird. I guess the lights thought there's no one in here, but CH4 is not an acid. It is methane. NH3 is actually a base, ammonia. But if I take, say, H2S, that's an acid. HCl is an acid. HBr is an acid. HI is an acid. All these things can be acids and will be named as an acid. Now, a base, which is going to be the opposite of an acid, is usually going to be a compound that when dissolved in water will produce hydroxide. An acid and a base will always react to form water and salt. So NaOH is our base, sodium hydroxide. HCl is our acid. If I mix them together, H plus OH gives you H2O, which is our water. The Cl and the Na can just combine together to form our NaCl, or table salt. But the big thing we have to worry about is naming our acids. Now, if an acid is a monoatomic anion, so that means if I have HCl, HBr, HI, H2S, we just add a hydro in front of it, and the IDE ending becomes IC acid. So instead of saying hydrogen bromide, we call it hydrobromic acid. Hydrogen chloride becomes hydrochloric acid. Hydrogen sulfide would be hydrosulfuric acid. Now, when we add the hydrogens to the polyatomic anions, it changes a little bit different. If it's just an ATE ending, we just change it to an ic acid. Because of the oxyanion or the polyatomic nature, the AT, we don't have the hydro. So acetate, which is the C2H3O2, the vinegar, becomes acetic acid. So I remove the 8 and put it is ic acid. Oxalate can become oxalic acid. And the same thing is going to be true for the oxyanions. The 8 will go to an ic acid. But the problem is some of our guys have an ite. The ite, instead of going to an ic acid, goes to an OUS acid. So hypobromite would become hypobromous acid. Sulfate becomes sulfuric acid, but sulfite would become sulfurous acid. So basically we have to learn that 8 goes to IC and ite goes to OUS. And that's what we're going to do with our acids. So it's just going to add one more little thing. Learn. It's not going to be a big part of the class right away, but it will play a small part, especially when I ask you need to use sulfuric acid. You need to be able to, oh, that's H2SO4. We're probably not going to use sulfurous acid, so you won't have to worry about it. But you'll at least be able to recognize, oh, sulfuric, that we take our SO4 and we add hydrogens to it. But so, and quick reminder, if there is a metal in there and not a hydrogen, it is not necessarily an acid. So KH2PO4 becomes potassium dihydrogen phosphate. We're literally saying we have a potassium, we have 2 hydrogens and a phosphate. This one's sodium hydrogen carbonate, or you could say sodium bicarbonate. Either one works. HF, so that's a monoanion hydrofluoric acid. Pretty dangerous acid. Hydroiodic acid, HI. H2SO4. So SO4 is sulfate. SO2 is sulfate. So H2SO4 is sulfuric acid. Let's say PO3 or no, that's PO3. Okay. So PO3 is phosphite, So H3PO3 would be phosphorus acid. Phosphorus acid. So this chart, for your benefit, don't worry about it. Basically, it's showing a scheme of how you could go about naming things. If this confuses you, don't worry about it. But basically, you can break it down into, is it ionic or is it covalent? Is it metal and metal, non-metal, or metal or non-metal, non-metal, and split it there. Then talk about like, oh, how do we name the cation? Is it a transition metal or not? Well, if it's a transition metal, we have to do it one way. If it's not a transition metal, we can name it the other. What about the anions? Is it a normal anion? Is it an oxyanion? And it just kind of goes through it. Kind of like the long form, one-page version of what we just spent the last class and a half on. But don't worry about that. So rather than start this math right now, I'm going to try to pull up some homework. So I'm going to see if I can do this without crashing the stream. Okay. Nope. It's going to do that, is it? Okay, put that back in there. Okay. Okay, we'll just do it like this. Sign in. Okay, now that's way. Oh, well, we'll deal with this in a minute. It would be a problem. That's good enough. Good enough. Okay, so quick reminder, course. Spend 5-10 minutes looking at some of the homework from chapter 3. Assuming I can get to that before it decides to we run out of time. Okay, here we go. Chapter 3. That's learning curve. Well, we'll just do some learning curve nomenclature. That works for me. Whatever gives us some practice is the idea here. Give us some practice. Otherwise, I'm going to be okay. So looking at this. Which compound is ionic? So for an ionic compound, we need metal and non-metal. So no matter what, the anion is going to be non-metal. So which one of these guys is the first element? Metal, and that'd be barium. Barium sulfide. Looking at this. Which compound is a molecular compound? We're looking at metal, we're non-metal and non-metal. So not strontium, not potassium, not radium. So sulfur. is the nonmetal. Because that's going to, so we would name that as, if that's S1, is it, I can't really see it from the side eye, is that S1Cl4 or is it S something else? Okay, so if that's S2Cl4, we'd call that disulfur tetrachloride. So which of these 4 compounds is composed of cadmium 2 and sulfate? Cadmium 2 sulfate. So I really can't see this too well from the side. Cadmium 2, it means 2 plus. Sulfate, here's the tricky part. Sulfate is SO4 2 minus. SO4 2 minus. So 2 plus, 2 minus will go together in a 1-to-1 ratio. So we're looking at one that needs to be CD SO4. No subscripts other than the 4 on the oxygen. So the options are CDSO4, CD2SO4, CDSO42, CD2SO42. So this is really odd that all the first ones are the right one. I assume this is some weird luck, but halfway done. Okay. Oh, geez. Okay. Okay. Which of these compounds would be titanium 2 sulfide? Once again, sulfur, group 6, 2 minus. 2 plus, 2 minus. This is just really odd that this is not always the case. And the last one, just to finish this off, would be like, which of these are going to be copper 2 phosphate? So copper 2, phosphate is PO4 3 minus. So 2 plus and 3 minus are not going to cancel out easily. So we have to have that greatest common factor between them. So once again, Cu3, PO4, 2. This is just creepy. Either they did this on purposely for the professor to make this easier, or what's the likelihood of like 6 questions all being A? So, so what you need to practice, and I'll give you some more practice if we can, is we need to be able to practice turning, is recognizing charges and combining them so they're neutral. Looking at the name, recognize what the charges are and combining them together so they're neutral. And then looking at the neutral compound, the formulas, and recognizing the names without too much difficulty. Recognizing, is this a transition metal or not? Is this an oxyanion or not? And what are some of these common oxyanion names? Learn your sulfate, your carbonate, your phosphate. Learn your perchlorate. Learn those and your nitrate. So carbonate, nitrate, phosphate, sulfate, perchlorate. If you learn those 5 starting points, everything else can be modified from them. Because perchlorate is identical to perbromate, is identical to periodate. Sulfate, if you recognize sulfate, you can get sulfite. If you recognize phosphate, you could get phosphite. If you recognize nitrate, you can get nitrite. Because you go, that's not quite the same. It's not quite the same as nitrate. It's 1 less. That may help just a pinch. Just a pinch. Okay, as far as we're going to get today. I know it's like, oh, we didn't get that far, but we are ready on Friday to look at the mathematical portion of this chapter, where we look at what is a mole, what is the grams, and hopefully we'll have a better go at it. Thank you for your time.